Alright, what we're going to do is a little bit of review, and we do have a new lesson today. But from here on out, folks, your review for both the mock and the real thing is going to be happening in warm-ups and homework, so please pay attention to both of those. Every year, they're going to put something about domain and range. If they ask you for domain, that should be super easy. What is it? All real numbers. Domain of any parabola, a normal, plain old parabola, whether you have an equation or a picture, it's all real numbers. Now, range is never all real numbers on a parabola. What does range depend on? The vertex. Specifically, the y value of the vertex. Okay, so let's put this in our calculator. Somebody asked me if you have to flip it around. You don't have to. You can leave it just like it is. If you want to flip it around, you can. But make sure you keep all the signs correct. This is a negative value for A. That means this thing is opening down. Now, I was originally in Zoom 6 and I couldn't see the whole thing. You can zoom out. Zooming out sometimes distorts the picture. All I really need to do is go a little bit higher. So I went to my window and I increased my Y maximum. It's only going up to 10 units high. I made it like 20 just to see if I could see it. And I could see it. So I want to know the range. That means I'm looking for the Y value of that vertex. Do y'all remember how to find vertex? Yeah, you can get the calculator to do it for you. Calculate a minimum or a maximum. In this case, you have to know it's a maximum. This is where it asks you for boundaries. When it wants a left boundary, make sure your cursor is to the left and hit enter. Then arrow pops up. Right boundary, it's asking for a right one. Go over to the right. Please make sure your vertex is in between your arrows. And don't stop till you see the word maximum. The reason why I didn't focus on this a lot is because the x value is not accurate. But the y value is. What does yours say? Mine says negative 0.999. What does yours say? Negative 1. Just negative 1? Okay, it depends on what you put in for boundaries. The actual x value is exactly negative 1. The y value, though, is accurate. The highest y value is 17. So what's the range here? Less than or equal to 17. Okay, the other way that I taught you, the main way I liked it was half brain, half calculator for finding vertex, where we did the opposite of b over 2a, because that gives me the absolute most, the accurate x value. The opposite of b here would be 2, positive 2, over 2 times a is negative 1, so 2 times negative 1. That means my x value is exactly negative 1. Then I could find the y value that goes with it just by looking at the t-chart. Tell my t-chart to start at negative 1 and it's 17. So the whole vertex was negative 117. For range, all I needed was the 17. Okay, let's keep going. Keep track of how many of these you're getting right, by the way, because again, all of these were from end of course exams in the recent past. Not really. If you're stuck on the first one, at least try the second one. We just did some of these yesterday. Alright, let's go over these. On number 1, I always start with 2. Can you divide this by 2? No. It's not even. Then I go to my next prime number, which is 3. You can divide this by 3. Now watch what's going to happen here, folks, because some of you kept going and you really didn't need to. 243 divided by 3 is 81. That is a giant perfect square right there. That's the biggest one you're going to find. So 243 is 81 times 3. And what's the square root of 81? 9. What stays in? The 3. Some kids kept going, and that's fine too. 243 divided by 3 is 81. 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Okay, but look what you're going to get. A pair of 3's, which is a 9. Another pair of 3's, which is a... And what do those make together? 81 times this leftover lonely 3. So even if you kept going, you still should get the same answer. The 81 comes out as a 9, and that 3 had to stay in there. All right, now, number 2. The second equation on number 2 is trickier, that second sentence. We've got a dog and a cat, and they ate 24 treats total. That part's easy. D plus C equals 24. The dog ate 6 fewer than twice the cat. In other words, the dog's treat consumption is 6 fewer than twice cat. Dog is 6 fewer than twice the cat. Sometimes they don't even ask you to solve it. They might ask you to pick the right system, because I still have some kids who are guessing and checking. Which, if they want the answers and that's your only method, that's fine. But if they want the equations, you got to match up the equations to the sentences. Plus, it's so much easier to write these equations and then solve it. I would probably do this one with substitution. Since D equals 2C minus 6, I'm going to take this D out and put a 2C minus 6 in its place. So then I have 2C minus 6 plus C equals 24. 3C minus 6 equals 24. 3C equals 30. So how many treats did that cat eat? 10. And there were 24 total treats, so the dog ate 14. Now, see how it matches both? The dog ate 6 fewer than twice the cat. What's twice the cat? And what's 6 fewer than that? See, it matches both situations. All right, now, this is new. Take your calculator, see if you can figure out what's happening here. How they move. Yes, a transformation moves it or changes its shape. That's what a transformation does. We have not really talked about these transformations yet. A lot of kids thought, yeah, it's going to go up. That is not what happens. It does not go down. It does not get wider or skinnier. Okay, if you're not sure what it does, let's put both of them in there. Y equals x squared is the parent function. You should know about y equals x squared. Now, look what they changed it to, and you got to do exactly what they did. They changed it to x plus 4.5 in parentheses, that's important, squared, and let's see what happens. There goes the parent function, here comes the new function. What happened to it? It moved the whole thing to the left. How many spaces? 4.5 spaces. Okay, so let's review some of the transformations we do know. Here's my parent function, y equals x squared. If I want to make it skinnier or wider, what do I change? The a. Like if I change it from y equals x squared to y equals 3x squared, what transformation is that? This one makes it more narrow. Are y'all with me? Remember our algebra aerobics? Here's y equals x squared, 3x squared, we get skinnier. How do I make it fatter? A fraction value of a. Y equals 1/2 x squared makes it fat. Fractions make you fat. What if I wanted it to open down instead of up? Make it negative. The negative just makes it go down instead of up. The other transformation that we've done quite a bit of is when you change the y-intercept. What is happening from here to here? The whole thing just goes up 5. This is the change that we haven't talked about. When you change the x inside parentheses, something kind of weird happens. That's when it's either going to move to the left or the right. And looking at this, a lot of kids would think it's going to go to the right. But it went to the left. And this is why. It's related to that format for the vertex form of a parabola. X minus h. Well, if x minus h turned into x plus 4.5, what was h really? Yeah, it was really negative. So it really was a left move, but it When you subtract a left, it turns that into a positive. You don't really need to understand it. You just need to look at this and describe what happened. What do you think would happen if I did x minus 6 squared? It would go to the right. How many spaces? 6. Okay, so if you take this and then subtract 6 from the x and then square it, that's a left and right move. And if you're not sure, look at it. Here's y equals x squared. That's the parent function. Oopsie, I erased it. Y equals x squared. Let's change that to y equals, in parentheses, x minus 6 squared. Here comes y equals x squared. That's the parent function. Here comes the second one I graphed. Look what it did. It went to the right. How many spaces? 6. Yeah, all of that gets squared. Well, it's going to become x squared minus 12x plus 36, but you want it to be in this form so you can see the change. Okay, try these, please. All right, folks, it's been a while. Please pay attention. There are 2 rules happening in this problem. One of them is when you raise a power to a power, like a squared raised to the 3rd power. What do you do there? No, you don't add them. You multiply them. Okay, and then the second rule is where you are multiplying powers of the same base. Now, what do you do there? That's where you add them. So it's the same concept with coefficients thrown in, with the 2 rules going on at once, and with a weird old fraction. First, you got to do the power of power rule. That's where the exponents get multiplied. Now, what about this coefficient? 3 gets squared just like always. Yes. What's 3 squared? 9. And x to the 4th gets squared, which becomes x to the 8th. Now, I'm going to multiply that by whatever I get for here. What's the coefficient here? 1. 1 to the 2/3 or 1 to any function, any power is still a 1. So I don't need to worry about the coefficient here. I just need to do the x. And if you don't like multiplying fractions, get your calculator to do it for you. What's 12 times 2/3? 8. Now I'm down to a multiplying problem. I've got a 9 coefficient and an invisible 1 coefficient. 9 times 1 is 9. What do I do with these guys? Add the exponents. That's 9x to the 16th. Do you want to try another one? I was just saying some kids wanted to do 1 times 2/3, but it's not 1 times 2/3, it's 1 to the 2/3 power. 1 to any power is still a 1. So if there's not a coefficient here, you don't even need to worry about it. Okay, so 2 to the 5th power. 2 to the 5th power is it 243? Two to the 5th is 32, isn't it? Okay, and then x to the 3rd to the 5th is x to the 15th times x to the 6th. 32 times 1 is still 32, and this becomes x to the what? 21. Alright, moving on, folks. Here's another transformation problem. I just want you to get used to how they are asking it. F of x equals x squared. That's the parent function. Then they're making a new function, and they're taking f of x, which is what now? X squared, and what are they doing to it? Multiplying it by 4. What would happen to this function if we multiplied it by 4? What would happen to it? It would get what? It would get skinnier. It would get narrower. It would get more narrow. We just talked about that. When you change A, it's either going to get fatter or skinnier, or it could make it open up. Open down instead of up. Multiplying by 4 is going to make it skinnier. The answer would be, describe it, it gets more narrow. That's the answer. Or you would pick the picture that showed it getting more narrow. Skinny. Okay. Now, here comes the new stuff. Exponential functions. New lesson. We just reviewed, now we're doing the new stuff. Exponential functions. What do you think exponential functions have in them? Exponents, absolutely. But lots of functions have exponents. What makes these special is the independent variable is the exponent. The independent variable is the exponent. There is a parent function for this, and it looks like this. Y equals 2 to the x power. So the exponent is actually the x, the input. I'm going to show you. Now, why do you think the parent function wouldn't be y equals 1 to the x? Normally they use a 1. Why wouldn't they put y equals 1 to the x instead of 2 to the x? What's 1 to any power? Still 1, so that's why they can't use a 1 here. Well, x could be anything. I'm telling you, the input is the thing that makes this different is the input is where the exponent goes. What? Okay, well, I'm not necessarily squaring the 2. I could put it, no, I'm not squaring the x. The base is 2, and I'm raising it to an x power. I could let x be anything. X could be 3. That means I'm not squaring the 2. What am I doing? You input the x. Oh my God, guys, I'm not asking you to find anything yet. I'm just asking you to understand that an exponential function means the input, where you put the x is where the exponent goes. Now, these are the ones that have asymptotes. You got to know about those as well. Let's look at this right here. Here's an exponential function. We've talked about these a little bit. Folks, what did I just talk to you about? Now, what is the asymptote for this problem? Y equals -2. That's the line that it's getting very, very close to, but it will never go below it. Yes, it is. Here's -1. It crosses through -1 and keeps on going, and it gets close to a y, but it never will cross that line. You got to understand what asymptotes are. You also need to understand that these have horizontal asymptotes. You'll need to be writing this down. Asymptote is the line it gets very close to, but it never crosses and never touches. And for these folks, it's always, always horizontal. You will never have an asymptote in Algebra 1 that goes up and down. They're horizontal. Keep that in mind. Because this edge of the picture continues to go to the left forever. This edge of the picture and up. This one goes to the right, but it doesn't go down forever. It never goes below that -2. What's the domain of these things? If it's just a plain old exponential function, it's all real numbers. The range depends on where that asymptote is. Not the vertex, the asymptote. This one would never go below -2, so what's the range of this guy? No. No. Y is greater than, not equal to, it will never equal. The range of this guy is y is greater than -2. Okay, let's do another one. What do you think the asymptote is here? Y equals 3 is the asymptote for this. That's this invisible line that it's approaching but will never ever cross. What's the range? What's the domain of this? What's the domain? All real numbers. What's the range? Y is less than 3. This will never go above that 3. Okay, now, one of the things that you do with exponential functions is exponential growth and decay. And this is like its own special little formula, but it's a use for exponential functions. Exponential growth and decay. Growth means it's getting bigger, going up. Decay means it's going down. Boys, you need to be writing this down. All right, growth, a growth model, you read a graph left to right. A growth model shows it going up as you move to the right. A decay model would be showing it going down as you move to the right. Okay, now, we do have a formula, and I do not think they give this to you. You've just got to know this. There's two different formulas, but they're very, very close. One's got a plus, one's got a minus. Which one do you think has a plus? The growth. Write that down, please. Y equals a parentheses 1 plus r raised to the t power. I will tell you what it is. Write it down. The decay model is very, very similar. Y equals a parentheses, instead of 1 plus r, it's 1 minus r. No. All right. On these problems, you always have to start with a certain amount. It could be a certain amount of money. It could be a certain amount of animals in a forest. It could be a certain amount of trees. It could be a certain amount of anything. A equals the initial amount of whatever it is you're talking about. A is what you're starting with, in other words. A is where you're starting. Now, inside parentheses, there's always a 1 there. It's either 1 plus r or 1 minus r. R equals the rate. The rate of growth or decay, depending on what you're looking at. Now, for this formula, for these problems, this rate is usually given as a percent. But you have to convert it to a decimal. The rate of growth is usually on these problems it's given to you as a percent, and you cannot put a percent into the formula. You've got to convert it to a decimal number. And then t equals the time, and it could be any unit of time. It's whatever unit of time you're talking about in the problem. It could be minutes, hours, weeks, months, years, whatever. Now, this is used for things that are constantly changing, where the amount is changing, like compound interest in a bank account. Because if you put money in an account and you leave it in there, well, after the first year, you've got a different amount of money, right? Because you've earned some interest and they're putting that into your account. So the second year, you're starting at a different amount. That's what this takes care of. All right. Well, this isn't simple. This would be more like compound. Okay, let's look at some problems. A car depreciates in value 12% per year. What do you think depreciates means? Goes down. So this is going to be decay, not growth. By 12% per year, the car starts. The car cost $19,500 when it was brand new, and we want to know how much it's going to be worth after 4 years. We're going to use our formula. Y equals a parentheses 1 plus r. Oh, I'm sorry, not plus, because this is going down. 1 minus r to the time power. Demetria, you better be writing this down. So what do I put in for A? 19,500. Now, watch out, folks, because they're going to ask you some tricky questions. This one's really not that bad. 1 minus 0.12. 1 minus 0.12, because 12% as a decimal is 0.12. So if they give it to you in percent, you've got to convert it to a decimal. Raised to the time power. So what would I put it for t? Yeah, put that in the calculator and see what it tells you. I'm serious. Okay, I got $11,694 and about 6 cents. Did y'all get that? 11,694.06. No. No, because it's happening every year. The second year, it's starting at a different value. You would have to do it 4 times. You'd have to do it the first year, find out the value when you start the second year, then you'd have to do it again for the third year. This is much faster. Okay, now look at this question. I'm going to change the numbers, but we're going to talk. It's the same kind of situation where we've got a car and it's depreciating in value, but I'm changing the numbers, and I'm going to already have everything plugged in, and I already simplified it a little bit. I want you to look at this. They asked this one year. Edwin, bring it to me. Bring it to me. Bring it to me now. Now. All right, look at this problem. Can you tell what the rate was? The rate is not 75. 25. Okay, because this was a 25% decrease. Because how did this become 0.75? It became 0.75 by doing 1 minus 0.25. So this was a 25% decrease, which means it's now going to be worth 75% of what it used to be worth. What was the original amount of this car? 2,000. How many years are we tracking its value? 5 years. All right, let's try another one. In this one, we're putting money in the bank. So in this case, we're earning interest. This would be a plus. Do this. No, it's not 0.32. You got to move the decimal twice. So 3.2% is the same thing as 0.032. So when we set up our equation, y equals 1,200, parentheses, what? 1 plus 0.032 raised to the third power. So 1,200, parentheses, 1 plus 0.032 raised to the third power. 1318.93-ish. 92 or 93 cents, it's either one. Okay, now look at this problem. Same thing, I'm putting money in a bank. How long am I leaving it in the bank? 7 years. Can you tell what my interest rate is? 5%. 5%, because 1 plus 0.05 is how we got this 1.05. How much money did I start with? $5,000. Okay, look at this problem. Y equals. Do you think this is growth or decay? Decay. Because if this is less than 1, it's decay. If it's bigger than 1, it's growth. This is decay. What's the initial amount I started with? What's the initial amount I started with? $10,000. How many years am I tracking this value? 5 years. Can you tell what the percent of decrease? It's not 2%. It's a 20% decrease because 1 minus 0.2 is how you get 0.8. Okay, what about this? Is this growth or decay? Growth, because it's bigger than 1. What's my original amount? What's my original amount? 800. How many years am I tracking it? What's my percent of increase? Okay. We're going to go over this again tomorrow, but we're running out of time. Okay, look at this one. What's my initial amount? 2,000. Is this going up or down? This is increase. This is a 2.5% increase. How many years or whatever? We don't know. We don't know. X could be anything. We don't know. Okay, now I'm going to throw a little curveball at you. Okay, this is a little bit different. Whoops. Double check, triple check, quadruple check. All right. Doubling, tripling, and quadrupling or whatever. Folks, please, this is a little bit different. I need y'all to pay attention. This is different than the ones we just did because it's not, the rate is not given to you as a percent. Okay, if the rate's not given to you as a percent, it's a little bit different. And it's actually simpler because this makes sense. If you're doubling something, what do you think you're going to multiply by? 2. If you're tripling something, what do you think you're going to multiply by? 3. If you're quadrupling something, 4. So let's talk about how we would set this one up. The initial amount still starts the same. What's the initial amount? Folks, 7. We were originally started with 7 bacteria cells. Now, instead of the 1 plus or minus business, they just told us that it triples. So what do you think I put in here? Just a 3. And what do I put for hours? To the H hours. Because they told me to use H. The exponent is always a time value on these problems. I don't always say x equals 1 in an equation. No, I said if you have an x in an equation, the coefficient is 1. I don't know what you're talking about. Alright, what if this had said doubling instead of tripling? If it doubles, then you would just have y equals 7 with a 2 in here to the h time. Okay. Now, your homework. Please listen up. From here on out, guys, I'm going to be giving you lots of little questions in class and also questions for homework. So I'm actually giving you a quiz for homework tonight. Please take this seriously. Please stop talking. If you're in the habit of not doing your homework, you better stop. Because the best way to prepare is to do old end-of-course items, and that's what these homework assignments and daily grades are going to be over. I'm about to pass out your little quiz for your homework. You better make sure you do it. It's about 10 questions long.